Hello everyone, I'm Zhang from the virtualization team of Intel Open Source Technology Center. And here I'd like to present the Intel new Resource Director technology. On behalf of my colleague Yi-Sun, he has been working on this feature enabling in Zen, and he's not here today. Okay. Here's the agenda. First is background introduction, the shared resource contention. Oops, it seems we don't have the... it should be moved here. Sorry. Okay, I need to rearrange my resolution. 太小了。Still, it cannot be sure.
切一下屏幕那个。切一下屏幕那个，不是那个，就是切两个屏幕的那个，不是这个，切那个 X10的那个。是这个。
Still, yeah, it's not working.
Second screen only， 你要不然就瞧着屏幕不行。
看这个。好。Yeah, that's okay. So, let me start. So, hello everyone, this is Zhang from Intel Open Source Technology Center, and I'm from the virtualization team. And today I'd like to introduce Intel new Resource Director technology feature, and it's a brief overview of the Zen Refactor efforts. And this speech is given on behalf of my colleague Yi-Sun, who has been working on this feature, and he's not here today. Okay. Here is a brief the agenda, and the first is a brief overview of the shared resource contention, and also Intel Resource Director technology to give us a solution for the resource contention. Also, I'd like to give a performance improvement proof. And next, I'd like to introduce some Intel new RDT features, which is L2 cache allocation technology and the memory bandwidth allocation. Also, last is a brief overview of the Zen Refactor based on the key characteristics of the shared resource allocation features. Okay, here is a figure showing an experiment which is performed years ago in Intel, and As you can see, the horizontal axis is a list of benchmark tools in, I guess, CPU benchmark 2006. And the vertical axis is the performance slowdown compared to running the test cases alone. So this test is performed on a hardware platform which has 4 CPU cores and with last level cache size being 8 megabytes. So you can see in the worst case is Sphinx 3, which is running when it is running with another test case, Leslie 3D. It will cause a performance slowdown to the maximum as 4.5 compared to running the test case alone. So one major reason for this performance impact is due to the shared resource contention. So as you know, software has many approaches to optimize the sharing of different kind of hardware. For the physical CPU, we have the real-time scheduler to guarantee the determinism for the high prioritized application of VM. Or we can pin the CPU for the special prioritized application. And for memory, we can achieve such optimization with cache-aware memory allocation algorithms. And we can also use dedicated memory region for a special requirement. And for I/O devices, we can just dedicate this device to a specific user. But for the platform shared resource like the cache and the memory bandwidth, software can do nothing until the arrival of Intel Resource Director technology. Okay. So as you can see, Intel Resource Director technology is a group of facilities which enables us to monitor and to allocate the shared resource like cache and memory bandwidth. We have the CMT, which is cache monitoring technology. It can monitor the cache occupancy based on the resource monitoring ID. And we also have the MBM, the memory bandwidth monitoring, which can monitor the memory bandwidth consumption of different usages. Also, we have the L3 CAT, which is L3 Cache Allocation technology, to partition and to isolation and to allocation the different last level caches to different usages. And we can guarantee the high prioritized requirements with comparably more greater size of last level cache, and we can limit the other low prioritized usages to using a shared last level cache with limited resources. And we also have CDP, which is code data prioritization. It can be considered as an extension of the last level CAT, L3 CAT, by applying separate configurations for the code and for the data. So all these features has already been supported in Zhang. So as you can see, this feature shows that the performance downgrade is reduced with L3 CAT enabled. Here in this figure, you can see out of the 8 megabytes of last level cache, 6 megabytes of them is allocated to a high prioritized application. And the remaining 2 megabytes is shared by 3 lower prioritized applications. And you can see here the Sphinx 3 test 2 is its performance downgrade is reduced to 1.5 when it's running together with Leslie 3D, which is previously the downgrade is 4.5 times, and this is a significant improvement. For now, this RDT features has been adopted by many companies like Google and Alibaba. And now Intel is introducing some new RDT features like L2 CAT, which is L2 Cache Allocation technology. It is very similar to the L3 CAT in the difference that L2 CAT manages the L2 cache, which is shared by different logical processors instead of different cores. And another difference is L2 CAT does not provide the CDP feature yet. And the L2 CAT is to manage the L2 cache allocation based on the class of service. As you know, the processor exposes a group of course ID, which is the identification of a class of service. And each course ID maps to a QoS bit mask, which is also called the capability bit mask, MSR. This MSR specifies how much memory cache lines can be allocated to a specific user. And it also specifies how the cache lines are overlapped or shared or separated, isolated between different applications. Okay, next page. Here is memory bandwidth allocation, the MBA. So with MBA, data transfers with lower prioritized applications can be throttled through the program request rate controller. So you can see the MBA also manages the memory bandwidth allocation, also based on the course ID. So different course IDs signifies different QoS throttling values. So about the throttling value, you can consider it as a percentage of delay. Software can detect the maximum throttling value with the CPU ID enumeration. And this value is considered to serve two usages. One is it signifies the biggest value that can be configured into the QoS throttling MSR. Another is that this maximum value can be used to as precision. For example, maximum value of throttling when it is, for example, 90. It means that the biggest value can be configured into the QoS throttling MSR is no greater than 19. And also it means that the throttling precision is 10. So if a throttling MSR is configured, for example, like 50, that means the memory bandwidth should be performed as 50% of the maximum memory bandwidth. And MSRs configured with something other than multiple of 10 in such case will be rounded down to something like the nearest multiple of 10. So you can see it's also between the L2 cache and the high-speed interconnect. And on some platforms, which the L2 cache is also the last level cache, it's between the memory controller. Okay. So this is a figure showing all the Intel RDT features. So as you can see, the L3 cache is shared between different cores and within the same socket. And L2 cache is shared between different logical processors. And as you can see, each logical processor has a corresponding MSR, which is IA32 PQR association. It is a logical MSR and contains two fields. One is IMID for the monitoring feature. Another is Cache ID for the allocation feature. Also, as you can see, there are a group of QoS MSRs. Each group signifies the RDT feature. For example, we have the L3 QoS MSR. We have the L2 QoS MSR. Both of these MSRs are bitmaps, which means how much cache length can be allocated to a specific application. And we also have the QoS throttling MSR. Each MSR is corresponding to a Cache ID, and the meaning of it is the percentage of memory bandwidth delay. So each time application or each time a VM is scheduled in, it will be assigned by the hypervisor or by the operating system Cache ID. And the PQR association MSR will be updated with the corresponding Cache ID. And then all these mask MSRs will take effect. And one thing is that different features of the RDT can take effect simultaneously. And all of these different RDT features share the same Cache ID. Although the maximum Cache ID value for different RDT feature can differ. Okay, so next we need to refactor the Zhang code, because as you can see from the left side is the current implementation in Zhang. The PSR.c is what we are doing for the RDT allocation feature. And as you can see, it's only used for the L3 cat and the CDP. It is not generic enough. So we need to extend that, refactor that data structure and the interfaces to accommodate the new features like L2 cat and the MBA. So as you can see from the right side of this page is a newly defined data structure. And there's a group of features, the array feature, which each element of this array signifies a specific RDT feature. And all of these features are contained in socket info. Also, a group of new interfaces are introduced to get and set the configuration of different RDT features. For the feature-specific requirements, we have several callback routines to implement the specific requirements.
Sorry, just a quick interruption here. We're 5 minutes over already on this.
Okay. So for now, we have sent out 13 versions of the L2 cat patch set. And for the 13th version, we have received quite a lot of review comments, and most of these patches have been reviewed by or got executed by. And we can expect these patches would be accepted in the near future. So next, we are going to support the MBA, and we'd like to refactor the tool stack to let the interfaces to be more generic. And supposedly, we will send out the patches very soon. Okay, that's all for this presentation. And
okay, I think we probably better defer questions. I think you have a design discussion this afternoon.
Okay.
So we should probably move straight on to, I think it's SGX and SGX virtualization.
Okay, thanks.